Okay, so we're just using conservation momentum, right? So we got our initial here, 6, 4. That is an initial of 24 to the right. This one is 2, negative 10. Don't forget the negatives, that's important. 2, negative 10, that's going to have an initial momentum negative 10. So the initial momentum of the system, if they ask you what's the initial momentum of the system, you would say it's 4. Okay? What's the final momentum of the system? 4. Because it's conserved. Alright, so we do have an issue here. What's our issue? Yeah, we have two unknowns, right? We have two unknown values in one equation. So what do we do when we encounter that situation? We need to find a second equation, right? If we can get two equations, two unknowns, then we can solve it. So that's what we're going to go ahead and do. Where are we going to get our other equation from? Good. Because I said it's completely elastic, we know an additional piece of information. What do we know? Kinetic initial is equal to kinetic final. Now be careful, you can only do this if they say it's completely elastic. Okay? If it's inelastic, you can't say that these are equal. You have to do it just with momentum. So we're going to get our second equation doing that. I'm going to simplify this one first. Let's divide by 2. So you get 2, 3 v6 plus v2. So that's our first equation. Our second equation, we're going to do it with kinetic energy. So kinetic of 6 plus kinetic of 2 initial should equal kinetic of 6 final plus kinetic of 2 final. Okay, what's the equation for kinetic? 1/2 mv squared, right. So go ahead and do it. Get ahead of me. I'll start doing it over here as well. Don't forget, when you square a negative, it does become positive. There's no such thing as negative kinetic energy. It's always going to be a positive number. Okay, so hopefully you got the same two equations I did. Okay, so that's our two equations, two unknowns. What do we do?
Substitution.
Yeah, substitute. We're going to solve for one, substitute in. Okay, so at this point it just becomes an algebra 1 problem. Okay, 8th grade, 7th grade math. So I'm going to solve for V2. It doesn't matter which one you do, though. This one seems easier. So solve for V2, right? Substitute that into the V2 squared. Okay, then we use like our FOIL method, right? So first is 4 minus 6v6 minus 6v6 plus 9v6 squared. Now most of the time you're going to have to end up using the quadratic equation to solve it. I tried to choose nice numbers so that you don't have to. But when in doubt... What was that? Oh, it's a nice thing. It's nice of you. Alright, so anyway, we're going to go ahead and solve this. So it's going to be 9v6... No, not 9. I messed up. What is that? 12. 12v6 squared minus 12v6 squared, v6, minus 144. That's not a square. Okay, we should simplify this a little bit. We can divide everything by 12, right? So that's going to give us v6 squared minus v6 minus 12. And that's basically it. That's an easy one for you to factor out, right? So I'll let you, flex your algebra muscles. You do get two answers, yeah. So if it wasn't so nice, you would have to use your quadratic. You would get two answers. This is what? v6 minus 4, v6 plus 3. So v6, what are the two answers? 4 or negative 3. Okay, so now you have to think about what's the wrong answer or what's the right answer. So go back to the original. Let's just look at what happened. Notice we're talking about 6 here, right? And we just said v6 is either 4 or negative 3. Well, what was v6 originally? 4. So is v6 finally going to also be 4? No. So basically what that would mean is that they missed. The two balls came towards each other and they missed. And so it's obviously going to be the same afterwards. And obviously energy and momentum would be conserved. So, but that's not what we're asking about. So that will always happen where one will be obviously wrong. So the right answer is 3, negative 3. Okay, and then how are we going to find v2? I don't think I can get it, but it's going to go way up here. Okay, so we're going to put our negative 3 way up into our v2 equation that we had earlier. Okay, so v2 equals 2 minus 3 minus 3. 11. Wasn't that fun?